Welcome to Lab 4, Part C, a case study. Case study. After a major storm in San Diego, a massive die-off of a particular snail species was observed along the shores of Mission Bay. It was hypothesized that fresh water from the storm flowed into Mission Bay and lowered salinity levels. In this lab section, we will explore whether the storm decreased the salinity in Mission Bay and whether decreased salinity was responsible for the massive die-off. Calculated salinity. An environmental station within Mission Bay performed conductivity measurements collected before, during, and after the storm. To determine whether the storm decreased salinity levels, calculate the salinity for each measured conductivity in the table. To do so, use your conductivity salinity equation that you formulated in Part A. For example, in our previous example in Part A, we determined that slope, or M, equaled 0.9, and the slope intercept, or B, was negative 0.5. In this equation, solve for Y, or salinity, based on X, the measured conductivity. However, remember that your equation may be different from this example depending on how you drew the slope of your line. Next, plot your calculated salinity versus time data on the graph. By creating a graph, we can better understand salinity levels in Mission Bay before, during, and after the storm. From information provided by the park rangers, we learned that the salinity tolerance of this snail species is known to range between approximately 32 and 48 parts per thousand. Thus, from the graph, we can determine pre-storm salinity values or levels, during the storm salinity levels, and post-storm salinity levels. Moreover, we can determine what time of day salinity levels were either within or out of tolerance, and again, this species of snail can only survive within the stated salinity level tolerances. Results. Thus, from our data, we can conclude that salinity levels did indeed decrease in Mission Bay during the storm's influx of fresh water. Salinity levels were out of tolerance for the snails during the day. However, we cannot assume that a change in salinity was the only cause leading to the massive die-off. An alternative hypothesis would be as rainwater runs across urban areas, bacteria, chemicals, or pollutants may have negatively affected the snail population. It's now time to complete lab assignment Part C, a case study. This concludes Lab 4, and please address your questions to your lab TA.